Rise over run. Good. And another way of saying that is y2 minus y1 over x2 minus x1. So that's when you have two different coordinates, and we're going to do some examples of this today, but it is rise over run. Delta y over delta x. And to translate it into real terms, y2 minus y1 over x2 minus x1. Do not forget this formula. It's very, very important. And we're going to be doing some examples using this formula today. Now, when we're talking about straight lines, that is part of the whole concept of the x and y values having a relationship. They're related to each other in some way, okay? So the definition of a mathematical relationship, when two quantities are related in some way, values that can change in a relationship are called variables. And we're going to talk about the concept of extrapolation and interpolation later on. So in the when we're talking about our graph, the independent variable, that's the variable that does not depend on the other. That is going to be represented by the horizontal axis. The dependent variable, which is the variable that depends on the other variable, is going to be represented by the vertical y-axis. So things like time. Can anything stop time? Steven, can anything stop time? No, right? Time doesn't depend on anything. No matter what happens in the world, time is going to keep going. So that would be an independent variable. And whenever we have a situation that involves time, time is going to be on the x-axis because it doesn't depend on anything, right? But for example, your height. If we're tracking the height of a child, are you going to shrink as time goes on? What's going to happen? Well, from at least until you're a teenager, what's going to happen to you, Angie? You're going to get taller. So, but your height is a dependent variable because it depends on time. I can't talk about you growing taller in one day, but I can track your height over a number of years, and your height is going to depend on time passing. So that relationship would be a linear relationship, but where time is the independent variable and the dependent variable would be your height. So independent variable, very often, time is a good example. And these particular definitions are going to be in your unit guide. Not every relationship, just because two things have a relationship with each other doesn't mean it's going to be a linear relationship. Over the next 4 years, you're going to be looking at lots of different types of graphs and names of different types of functions or graphs. But we're going to go over how to prove whether something is a linear relationship. Did you guys ever do first differences before? In elementary school? No? Okay, we're going to talk about it in a little bit. But first, let's go over assignment E in your unit guide. For those of you who have done Unit 7, you might want to pull out your Unit 7 guide right now just to make sure. We're going to talk about, let's label the dependent variable and independent variable in this case. So in red, I'm going to highlight the dependent variable, and in blue, the independent variable. So these are actually examples from assignment E that I want us to do together as a group. So the very first question, the distance a jogger runs depends on the length of time she runs. So which is going to be my independent variable and which is going to be my dependent variable? What do you think? Yep. Independent variable is time, okay. And what is my dependent variable? The what? Distance. Good. Distance is going to, oops, that's the same color. That's not what I wanted to do. So the distance is going to be my dependent variable. So my dependent variable, is that plotted on my y-axis or my x-axis? Tiana? The dependent variable. The dependent variable is on your y-axis. Independent variable is always on the x-axis. Okay, so time is always plotted on the x-axis. Okay, a recipe for 24 cookies requires 4 cups of flour. So what would I plot on my x-axis? What would I plot on my y-axis? Think about if you were going to put this in a graph. What would you do? So, can I only make cookies with flour? Are cookies the only thing I can make with flour? Is flour dependent on the recipe? No. Okay, so think about it. I could make lots of things with flour. I could even do paper mache with flour, right? Flour does not depend on the recipe. We can do so many different things with cups of flour. So this is going to be my independent variable, is the cups of flour. I'm going to plot on the x-axis, 1, 2, 3, 4, 5, 6. However, what depends on the flour? We cannot make the cookies without the flour, right? So my recipe for the number of cookies is going to depend on the flour. Does that make sense? Okay. What about the next one? A building must have 6 fire alarms. This is a little bit tricky. 6 fire alarms on each floor. Stephen, you want to try it? Okay, yeah. So it'll be a little tricky to kind of graph that situation, right? Well, actually, what would we put on the x-axis? What would we put on the y-axis? Because if we want to plot this situation, I know I can calculate the total number of fire alarms, right? We have the total number of fire alarms and we have the floors of the building. Which is going to be the dependent variable? Which is going to be the independent variable? What do you guys think? The floors of the buildings or the number of fire alarms? Does anyone have any idea if I wanted to plot this? Yep. The independent, right? Independent variable. This is going to be on my x-axis because no matter what, where the building is going to have a certain number of floors. But the number of fire alarms, right, is going to increase depending on each floor. If I was only plotting the graph for 4 floors, how many fire alarms would I have in total? 4 floors, 6 fire alarms on each floor. Allegra? 24. Good. So the fire alarms, the total number of fire alarms, is going to increase like steadily. We'll have a linear relationship, but the fire alarms are going to be on the y-axis. The floors are going to be on the x-axis. So whenever it's a little bit of tricky situation, try to picture in your head how you would actually draw out this graph, right? Let's do another one. The printing cost for the school newspaper drops 1 cent for every page over 50. So how would we plot this? What are the two things? What would be on the x-axis? What would be on the y-axis? I want some discussion. Yep. So the number of pages, right? Because no matter what, the pages don't depend on everything, but what does depend on the pages? The number of pages. Yep. Kind of. What's another word for this whole thing? Yep. The printing cost. Yeah, exactly. The cost, because that 1 cent is going to be how we calculate the cost, but the actual printing cost is the dependent variable. That's what's going to be on the y-axis, right? Because it could go like this and then it could drop or whatever, but no matter what, the number of pages does not depend on the printing cost. The cost depends on the number of pages. Okay, the manager wants to know how many cartons are needed to package orange juice.